100 billion suns, not a galaxy, not a cluster of stars scattered across millions of light years. One object, one shadow, 100 billion solar masses, compressed into a singularity so violent that the laws of physics, the same laws that govern everything you have ever seen, touched, or understood, simply stop working inside it. We thought Ton 6 and 18 was the end of the line. 66 billion solar masses. We called it the largest black hole ever measured. We assumed nothing in this universe could exceed it. We were wrong. 5.7 billion light years away, buried at the heart of the Phoenix cluster, one of the most massive galaxy clusters ever mapped, there sits something that has no right to exist. Its name is Phoenix A. And when scientists looked at it closely enough to measure its mass, they had to invent an entirely new category just to describe what they were seeing. The Phoenix cluster itself is already a place of extremes. It spans roughly 7 million light years across. A structure so enormous that our entire Milky Way galaxy would be a single dust particle if you dropped it inside. The cluster contains hundreds of individual galaxies, each one holding billions of stars. And at the center of all of it, like a king sitting on a throne built from the bones of 1,000 galaxies, is Phoenix A. The first measurements came through X-ray telescopes. Instruments designed to detect the superheated gas swirling around the most extreme objects in the universe. What they found shattered the existing scale of reference. Phoenix A has a mass of approximately 100 billion suns. Let that land for a moment. The Milky Way, our galaxy, contains somewhere between 200 and 400 billion stars, every single one of them. All the light you see when you look up at a clear night sky, all of it combined, doesn't match the mass of this one black hole. Its event horizon, the point of no return, the border where light itself cannot escape, stretches roughly 590 billion kilometers across. For comparison, the distance from our sun to Pluto is 5.9 billion kilometers. That means you could line up 100 complete solar systems. Sun, Mercury, Venus, Earth, Mars, all the gas giants, all the moons, the entire Kuiper belt, and every single one of them would disappear inside Phoenix A without touching the edges. If Phoenix A replaced our sun at the center of our solar system, its shadow would extend past the Oort cloud. It wouldn't eat our planets. It would eat our stellar neighborhood. Dozens of neighboring star systems would fall within its event horizon before the boundary even reached its outer edge. If this idea is making your mind reel, you're exactly where you're supposed to be. Subscribe to Beyond Orbit. Every week, we go somewhere the textbooks are afraid to follow. But here is the part that genuinely frightened the astrophysics community. Phoenix A shouldn't exist. Not because of its size alone, but because of the timeline. Black holes grow by consuming. They pull in gas, dust, and stars. They swallow neighboring objects. They merge with other black holes. Over billions of years, the most voracious ones become ultramassive. But there is a natural speed limit to this process. It's called the Eddington limit, a physical ceiling on how fast a black hole can feed. When a black hole consumes too aggressively, the radiation it generates during feeding becomes so intense that it pushes surrounding gas away. The black hole essentially chokes its own food supply. It regulates itself. Under normal conditions, even in the most favorable cosmic environments, a black hole feeding at its absolute maximum rate For the entire 13.8 billion year history of the universe should not be able to reach 100 billion solar masses. The universe is not old enough for Phoenix A to be what it is. So what happened? Scientists have been forced to consider two deeply unsettling possibilities. The first, Phoenix A didn't grow by eating stars. It grew by eating other black holes, massive ones. In the early universe, when galaxies were colliding constantly and the cosmic density was almost incomprehensible, ultra-massive black holes may have merged repeatedly, bypassing the Eddington limit entirely. No gas needed, no radiation flare-up, just two abysses combining into one deeper abyss, over and over and over, across billions of years until what remained was singular and absolute. The second possibility is stranger. Phoenix A may be what cosmologists call a primordial black hole. Not a black hole born from the collapse of a star, not a product of galactic evolution, a flaw in space-time itself, forged in the first fraction of a second after the Big Bang, when the entire universe was compressed into an almost infinitely dense, almost infinitely hot point of pure energy. In the chaos of that first moment, quantum fluctuations may have collapsed certain regions of space into singularities before a single star had ever ignited. If that's true, Phoenix A is older than every star in the observable universe. It was born in the dark. It has been feeding in the dark for longer than light itself has existed, and it may not be alone. Now here is where Phoenix A becomes something even more difficult to categorize. We expect black holes to be destroyers, gravity without mercy, consumption without purpose, but Phoenix A is doing something that contradicts the entire expected narrative. At its poles, Phoenix A is launching jets of relativistic plasma, streams of superheated particles moving at a significant fraction of the speed of light, stretching millions of light years out into the surrounding cosmos. The energy released in these jets is beyond any human engineering analogy. They are among the most powerful continuous energy outputs in the observable universe. And these jets are creating stars. When the plasma jets slam into the cold molecular gas clouds surrounding the Phoenix Cluster's central galaxy, the pressure triggers collapse. Gas that might have drifted for billions of years undisturbed suddenly contracts, heats, and ignites. The rate of star formation in the galaxy surrounding Phoenix A is approximately 740 new stars per year. Stars similar in size to our own sun. For context, the Milky Way in an average year produces one or two. Phoenix AA is not merely consuming its galaxy, it is building it. It is forcing the universe to create, at a rate that staggers any comparison. An ongoing explosion of new stellar life, powered entirely by the energy of its own hunger. It is simultaneously the most destructive and most generative object in its region of the cosmos. A destroyer that creates. A void that lights the dark. Tell me in the comments, does something this contradictory feel more like a force of nature to you, or something closer to what ancient humans might have called a god? I read every single response. We will not be around to watch Phoenix A die, long after our sun has exhausted its fuel and collapsed into a cold white dwarf, long after the Milky Way and Andromeda have merged, and their combined stars have burned out one by one, long after the last red dwarf in the universe has dimmed to nothing and the cosmos has entered its final era of cold and darkness. Phoenix A will still be there, sitting in silence, slowly evaporating through a process called Hawking radiation, A quantum-level trickle of energy so slow that the number of years required to fully evaporate Phoenix A would fill more pages than there are atoms in the observable universe. It will outlast everything, and as it sits there, in the absolute darkness of a dead universe, it will have no awareness of the trillion stars it created, the galaxies it shaped, or the small blue planet that once pointed instruments at it, and struggled to comprehend what it was looking at. We argued over borders, over resources, over status. We built monuments to ourselves and called them eternal. And 5.7 billion light years away, something with the mass of 100 billion suns was already old before the first star in our galaxy had ever formed. The universe does not measure us. Phoenix A simply is. And in the silence between galaxies, that is somehow the most terrifying and the most beautiful thing we have ever found. Keep looking up.